Okay, so now we're going to start thinking about how to convert between different units. I think we did a little bit of this already in lab, so maybe some of this will be a review. We're going to get through unit conversion, and we'll probably start or talk a little bit about acid-base chemistry. I'm hoping to try to give you like new topics or new material on Wednesdays, and then on Fridays we'll mostly be talking about different chemical demonstrations. And I've got a couple exciting things in store. Hopefully they'll be a little bit exciting and a little bit different and a little bit new. And I just want to make clear that I understand this is your first year seminar. You've got 4 classes, and now you're trying to learn remotely. I don't, by any stretch of the imagine, think that this should be your highest priority, or that we should be. I should be giving you the most work in this class, and so you know, the workload and everything should feel very, very familiar to what you've done before. We're going to cover a topic, and then we're going to give you some problems to work on. And we talked a little bit about that, and I talked a little bit about that in that video on Monday. Um, so we're starting here by talking about this idea of units, and units are like the label for different numbers. All right, and what I mean by the label is I sort of look at them almost like the clothing. They give us an idea of what a measured value means. If I say 6.524, you don't exactly know what it means other than that it's a number unless we have the unit attached to it. And so a couple things here that are important to understand about units are, number one, units are standardized, so they have to be tied to some type of a physical measurement, so that it gives them that meaning that that unit provides to that number. And so a good example of that is, you know, I suspect that most of you have probably driven some type of vehicle, or you've certainly been in a vehicle that had been driven. And if you go to the gas station, of course, almost all gas stations are pump gas stations, unless you're one of the folks that live in New Jersey, where all the gas pumps, essentially, gas is pumped for you. Uh, you'll go and you'll find a little sticker, and the sticker will say that this pump has been calibrated by some particular scientist or governmental agency. And that's to ensure that whenever you pump a gallon at it, it's the same as everyone else would get from a gas pump anywhere in the state of Pennsylvania. And the states all do this; they all have these calibrated to make sure that you're not, um, getting scammed whenever you go and buy it. So maybe one would set it and where you're only getting 0.75 or 75% of a gallon whenever it tells you or you're paying for a gallon. They can't do that. So this is to keep you from getting ripped off. It comes back to the day when you'd go into the grocery store and a lot of things would be purchased by weight or mass. And you probably know this already. You go in to buy fruit, and it's all by mass. But there's such a thing as, talking about putting your thumb on the scale whenever you're trying to, maybe you're showing favoritism or something like that. In this case, the person who might be behind the counter could actually put their thumb on the scale, and therefore the reading on the scale would be larger than what it normally would be or what it should be for the amount of stuff that's on there, and you're paying more to get less stuff. So there are these measures, and it's important that we understand units so that we can understand that. Um, and the different types of units that we have to worry about, or the base units, the standardized units, are first there for a number of different things. So mass and volume and distance and time. Those are things that we need units to be able to describe. The general units that we would use are the standard units, the ones that have been tied to particular chemical measurements. Are liters, meters, seconds, and grams actually is not a standard unit. Kilogram is actually the standard unit for mass, but we're used to seeing things in terms of grams. And so it's important that we're it's important that we can explain different masses in terms of these particular units. That's really what we're endeavoring to do. It may not make sense to always use grams, but maybe there will be some groupings of grams that would be useful. Like, for instance, if someone said, "What's the mass of your body?" Reporting that in grams wouldn't necessarily be super useful, because gram is a small unit. It's small in magnitude in terms of mass. Um, and it's important that you use those units because, and this bites scientists as well. So the Mars Polar Lander was sent to Mars with the intention that it would study the surface of Mars to determine if there were any signs of life. And in particular, it'd be looking for two different things. It'd be looking for organic molecules, those made of carbon, hydrogen, oxygen, nitrogen, and it would also be looking for water. And so the lander was supposed to go down and land, and there were a number of different instruments on here. So there were there's like a mass spectrometer, I believe. I don't. This one doesn't. Yeah, a MALDI mass spectrometer, I think, is what was on here. Thermal analyzer, gas analyzer. There are a number of different things or different parts of this lander. Um, and so it was designed to go down and measure and try to determine these things in the south polar region of Mars. Turns out NASA lost communication with the lander. It had come into the atmosphere. It was going to go down and land. It entered the atmosphere, and they lost all control of it. No communication, no nothing. And it turns out that, whenever you build a satellite like this, there's not one company that builds every single part. No company has the expertise that needs to build all those different parts. So instead, different companies or different contractors will build different parts of that. And so they do, and they bring it all together. They put it in one package. They put it on the rocket ship or on the I guess it could be on the space shuttle, although there is no space shuttle that's flying anymore, but at the time there was. And then it's taken up into outer space. This would have been launched on a rocket so that it could then be propelled towards Mars. But it turns out that the different units, the different groups of engineers use different units. Some used English measure like foot, inches, things like that, pints, quarts, gallons. The other used meters, kilograms, seconds. And so that's a problem whenever your engineers aren't using the same units. And it really surprises me that any engineers would not be using metric system at this point. That really surprises me, but it happens. And so the lesson is you got to include your units along with your numerical answers. I always like to call it, you want to make sure that your numbers are dressed up, that they're not naked. And that's sort of how I think about it. Now, when I talked before, I said the idea that using a gram is probably not the best way to report what the mass of your body would be, and so we can then group different amounts. So we can say, okay, instead of using grams, let's use groupings of 1,000 grams at a time, or we can say, okay, might want to do groupings of, 10 to the sixth grams at a time, and so there are these. If we're going to use groupings of 1,000 grams, we could use a prefix on there, and it could define what the size of that grouping would be. So we could say a kilogram, where a kilogram is 1,000 grams. Here I have everything written in terms of meters because these prefixes can be used for pretty much anything. It doesn't just have to be grams. It can be meters. It can be time. It can be whatever unit you want. We can put metric unit you want. We can put these prefixes in the front of them. And so here, if we look at mega is a million. All right, and that means that 1 meter would be 10 to the minus 6th megameters. If we've got kilo, all right, kilo is 1,000. It would mean that 1 meter is 10 to the minus 3rd kilometers. Deci is 0.1, all right? 1 meter would be 10 decimeters. Centi is 100th, all right? Which means 1 meter would have 100 centimeters in it. Milli, for a millimeter, is 1,000th. That would mean there are 1,000 millimeters in 1 meter. And then micro is abbreviated as mu, the Greek term mu. That's 100,000th, or 1 millionth, I guess. What's 1 millionth? And it would be 10 to the 6th micrometers in 1 meter, or 10 to the 6th micrometers. You can say it either way. It's important that we can go back and forth between these particular prefixes. So you can so that we can convert back and forth between the different groupings. So how many kilometers or how many meters are in a kilometer, for instance. Now it turns out that those units can be, the same things can be done with those, multiplication, adding, subtracting, division. We can do all those things with units in the same way that we do with them with numbers. And so whenever we have the unit attached to a number, we are just going to treat them in the same way that we would the number itself. So you're going to see that in the next problem where we're going to go ahead and we're going to convert between meters to centimeters. Now the nice thing about these videos, and it's different than a lecture, is, whenever I'm lecturing up in front of the class, a lot of times I'll find that there are some students who think I go too slow, and there are some students that think I go too quickly. So these videos I'm tending to go a little bit more quickly than I normally would when I'm in the classroom, because I don't have to wait for you to write. And so what you can do is when you get to the point where you get to a slide and you're like, I'm not done writing about this or taking notes about this, just pause the video and then you can finish writing, unpause it, and you can go on to the next slide. So you can sort of work at your own pace, which is really a kind of a nice benefit of this. I'm always trying to find silver linings of the fact that we're learning remotely and not learning together in the classroom. And I know that'll be a struggle for some of you. It's a struggle for me having to lecture like this. But here's an example problem. We're going to convert 1.275 meters to centimeters. All right. And so what we want to do, we're going to use something called the unit factor method. I like to call it a fence post. Sometimes it looks like a fence post. I'm going to write it like this. I'm starting with the number 1.275 meters. And then I'm going to put a parenthesis with a fraction inside of it, but I'm not going to indicate what the fraction is quite yet. I'm going to look at the unit, and the unit's going to tell me what the fraction should have, or at least what unit the fraction should have. So I have meter here, and if I want meters to go away and I want to end up with centimeters, I would have to have meter on the bottom. So that now this meter would be the top of the fraction, and this would be on the bottom, and they would cross out. All right, they would cancel. And now I want to convert between meters and centimeters, and I know that I have a conversion factor in the metric system prefixes to be able to go from meters to centimeters. So I want to end up with a unit of centimeter. Now, you're going to see in some of the problems coming up that we're going to have to be careful of how we do this because the conversion is not going to be so simple. Like the metric prefixes tell us about meters, all right, going from a meter to a kilometer, or going from a micrometer to a meter, all right? But it doesn't tell us about going from a micrometer to a kilometer, and we're going to see that in one of the next problems here coming up. But we know here from this chart, 1 meter is, all right, how many centimeters? It's 100. So 1 meter is 100 centimeters, and now when I multiply everything out, the unit that's left standing, the winner of the rumble here, is the centimeter, and that's going to be the unit. So I'm going to end up with 127.5 centimeters. Now, you might say, how do you solve that? I'm going to talk about it for this one, and then I'm going to sort of skim over it on the next one. Again, always send me a remind message if you're not sure. So 1.275 times 100 divided by 1. So I'm going to multiply everything across the numerators, across the top of the fractions, and I'm going to multiply everything across the bottom of the fraction. So I'd get 127.5 over 1, which is the same as 127.5. All right, so the next problem is going to talk about how to convert between millimeters and micrometers. So I'm starting with whatever number is given, 7.57 times 10 to the 6th micrometers. And I know that in my first conversion factor, the bottom has to be micrometer. Why? Because I want that unit to cross out. And then I know what the conversion is between micrometers and meters. I don't know what it is between micrometers and millimeters. All right. You might know, you can look those things up, but I'm telling you, I find it much easier to go back to the base unit, the meter, and know that 1 meter is 10 to the 6th micrometers. Then, now if I stopped, the unit that would be left is meter, so I would have converted to meter. But I don't want to stop at meter, I want to find millimeter. So meter has to come on the bottom so that those units will cross out. And then I want to end up at millimeter. Well, I know that 1 meter is 1,000 millimeters. All right. If I stop now, the unit's millimeter, so I've gotten to the correct unit. That's where I want to go. Now I'm going to multiply everything across the top and everything across the bottom. All right. And so I get 7.57 times 10 to the 9th over 1 times 10 to the 6th, and that unit is millimeter. Now when I divide those two things, 7.57 times 10 to the 9th over 1 times 10 to the 6th, I get 7,570 millimeters. Okay? Not terrible, right? Let's try just one more. And this one we're going to throw a little bit of a wrench into this. And it's going to make the math a little bit harder. Probably one of the harder or more challenging mathematical calculations we're going to do for the entire semester. And that is, what happens if we're dealing with a volume or we're dealing with an area? So how many cubic centimeters are in 1 kilometer? So 1.00 kilometer, and I want to convert to centimeters. Well, I know how to go between kilometers and meters. All right, so I know that there are 1,000 meters in 1 kilometer. Why does kilometer go on the bottom? Because it's the same unit I have here, and I want it to cross out, and I want to convert to meters. Then I can convert from meters to centimeter next. But something's different here is that I have cubic kilometers, and I only have kilometers here. So I need cubic kilometers. I need to cube that entire term. All right? And that may already be driving your head batty. You may have alarm bells going off. That's okay. We're going to figure it out. So next unit, I got the kilometer is going to cross out. Meter's got to be on the bottom. And I want to end up at centimeters. And I know that 1 meter is 100 centimeters. But it's not meter, it's cubic meter. So I've got to cube that term. And that way I know I'm going to end up with cubic centimeters. Now, what I would suggest that you do is I would suggest that you go ahead and you type these into the calculator. All right? Do all this stuff here first. So I'm going to rewrite the problem. 1 cubic kilometer, 1 cubed, 1 times 1 times 1 is 1. Kilometer cubed, so I'm cubing everything. Meter cubed. And if we look at 1,000, 1,000 is the same as 10 to the third. 10 to the third cubed is 10 to the 9th. You may not know that. You may need to use a calculator. That's okay. Go ahead and use a calculator to do that. Here I know that 100, and my pen is dying, so I'm switching to this blue one. All right, so I know 100 is 10 squared. 10 squared cubed is 10 to the 6th. Centimeter cubed is centimeter cubed. 1 cubed is 1. The unit meter cubed is meters cubed. Now notice things start to cancel out. So kilometers cancel. Meters cubed canceled. I'm left with centimeter cubed. Now I can punch this all into my calculator. Now, be careful. 10 to the 9th is the same as saying 1 times 10 to the 9th. 10 to the 6th is the same as saying 1 times 10 to the 6th. All right? That's not 10 times 10 to the ninth, and that's not 10 times 10 to the sixth. It's 1 times 10 to the ninth, or 1 times 10 to the sixth. And when you punch that all into your calculator, everything in the bottom is going to be a 1. You're going to end up with 1 times 10 to the 15th, and that's going to be cubic centimeters. Okay, that's it for unit conversion. You can go ahead and start working on the problems. I have a couple other example videos for you to watch. Yeah, have a great day.